Hello dear students, in this session we are going to learn working of AC generator, principle of AC generator and theory of AC generator. First we will see what is a generator. Generator is a device which converts mechanical energy into electrical energy. If your generator generates a current which changes its direction with respect to time, if the direction of generated current changes, alternates, then the corresponding generator we call it as alternating generator or AC generator. Okay, what is the principle? AC generator works on the principle of electromagnetic induction. That is, whenever the magnetic flux linked with the coil changes, EMF is induced through the coil. So by exploiting that concept, we are constructing an AC generator. Let us see how the construction of AC generator is. So here there are two magnets. Okay, these two magnets are used to produce a uniform magnetic field. So definitely magnetic field is from north to south. So here we have a armature coil. So here there is a coil PQRS. Okay, and the end of this QR is connected to one ring. Okay, this ring I call it as R1. This ring I call it as R1. Okay, it is connected to the ring R1 through a metal brush. Okay, through a metal brush B1. Why metal brush? Is because when the coil rotates, that metal brush also should rotate through the ring. Means there should be always contact between metal brush and the ring. That is why we have to use metal brush. And this wire connected to PS is connected to another ring. I call that ring as R2. So this is also a metal brush. Okay, now here what happens? According to Fleming's right hand rule, okay, the direction of induced current is given by Fleming's right hand rule. We also call that rule as dynamo rule. So if the forefinger points the direction of magnetic field, and if the thumb gives the direction of motion of conductor, say this is PQRS, say this is the coil PQRS, say the coil is rotating like this. See, the coil is rotating like this. What does it mean? This QR is coming out. Okay, means this is coming out, right? So using right hand rule, forefinger should show the direction of magnetic field, thumb should give the direction of motion of conductor. Okay, QR is coming out, then the central finger gives the direction of current induced. Yeah, this is the direction of current is induced. Now what happens? This current goes here, it comes here. Okay, the current comes here, and that current goes to R2. Since there is a metal brush here, that current goes to R2. From R2, the current passes through the resistor in this direction. Okay, now, okay, after half rotation, now this is the situation, correct? Now this is the situation. Yeah, see, this is P, Q, R, S. After half rotation, see, this is the rotation. Now where is P? P is here, Q is here, R is here, S is here. Correct now? Now what is happening? Now again it is coming. See, since the coil is rotating in the same direction, correct now? Initially P, Q, R, S rotates, half rotation. Okay. Then again it should rotate, right? So after half rotation, this PS is coming out. Okay. You can visualize it. I'll see. This is P, Q, R, S. Okay. After half rotation, the P comes here, Q comes here, S comes here, and R comes here. See. Now again it should rotate like this. So now the one complete rotation is over, right? So after half rotation, this part is coming out now, correct now? So if PS is coming out, forefinger gives the direction of magnetic field, thumb is giving the direction of motion of conductor, PS is coming out, then the central finger is showing that it will give you the direction of current. So the current is upwards. Current is upwards. Now, if PS is coming out, QR is going in. If QR is going in, see, magnetic field, direction of motion of conductor, inside, direction of current, down, correct now? So, what does it mean? Initially, in QR, current was going up. After half rotation in QR, current is coming down. Or this current comes here, goes to ring 1. From ring 1, it will flow through the resistor in this direction. Okay, then it will come to R2, then it will come to R2, and it will come here. The circuit is completed. Okay, now what is happening? You see, initially current was going from R to Q. Here current is coming from Q to R. You can observe here, there is a potential drop across the resistor initially in this direction, after half rotation in this direction. Means within a cycle, the direction of current produced alternates, changes with respect to time. That is why we call this current generated as alternating current. Now you see, what is the flux linked with the coil? Flux linked with the coil is given by BA cos theta. Flux linked with the coil is given by BA cos theta. If there are n number of turns in the coil, we call it as NBA cos theta. Now, what is theta? Theta means angular displacement. Now, if this coil is rotating with a constant angular velocity omega t, then theta is equal to, if you use the formula omega naught t plus half alpha t square, omega naught t plus half alpha t square, theta will be equal to, initial angular velocity will be omega into t. Since coil is rotating with constant angular velocity, angular acceleration is 0. So therefore theta is equal to omega t. Flux will be therefore equal to NBA cos omega t. NBA cos omega t. Now according to Faraday's laws of electromagnetic induction, E is equal to minus d phi by dt. Now what happens? E equal to minus d by dt of what is phi? Phi is NBA cos omega t. NBA cos omega t. Now what is N? N means number of turns in the coil, that is a constant. B means magnetic field. So we have used field magnets to produce uniform magnetic field. Then A means area of cross section of the coil, that is also constant. So what do? We can take that NBA outside. E is equal to minus NBA into differentiation of cos omega t. Differentiation of cos omega t. So what is differentiation of cos AX? Differentiation of cos AX is equal to minus sin AX into A, correct na? Minus sin AX into A, minus A sin AX. So here induced EMF is therefore equal to minus NBA into differentiation of cos omega t is minus sin omega t into omega, minus sin omega t into omega. Now what happens? This minus gets cancelled. EMF is equal to NBA omega into sin omega t. Now what is the maximum value of sin omega t? Maximum value of sin omega t will be equal to 1. Therefore, maximum value of induced EMF will be NBA omega, or I can write it as E is equal to E maximum EM into sin omega t. So where the maximum value of induced EMF EM is given by NBA omega. Now you can see induced EMF in the coil is varying sinusoidally. Means if you plot a graph of induced EMF versus time, you get a graph something like this, wherein this is plus EM, this is minus EM. And if you calculate the average value of induced EMF in one cycle, that average value will be equal to 0, because this is plus and this is minus. Yeah, now this is the final expression. E is equal to EM sin omega t. So this is the theory of AC generator. Hope you understood this. Thank you very much.